Hello everyone, this is going to be a short video for digital logic and computer systems, and it will be a short tutorial about how to make switch and LED circuits using your breadboard and some of the derivations behind it. So let's go ahead and jump into it. So here I went ahead and set up a breadboard with what you would typically see with a switch and LED circuit. So I'll go ahead and point out the main components that you should be able to replicate when you come to lab and when you take your lab quiz. So first off, if we look here on the left, this is going to be our switch package as well as our SIP resistor package. So although mine is pretty old and a lot of the text is worn off, all of these switches are labeled from here 1 all the way here to switch 8. So when you wire up this SIP resistor, there's an important thing to note. So I'll go ahead and take it out of the breadboard. So with this resistor, you can see one side, you have some text, black text. On the other side, there's nothing. So on this side with black text, you'll see on the left side, there's a small dot on the leftmost lead. So this indicates where your power is going to go. So you want to supply power to this leftmost lead, and then all of the following leads will go through the resistance into your switches. So when you're in a lab quiz or anything like that, make sure when you're looking at this resistor, this left dot, when you're reading the text, is on the left. So this yellow wire right here is connected to our red power rail. So we bring this power onto the breadboard, and then we'll go ahead and plug this SIP resistor back into the board. So now this yellow wire supplies power to our leftmost lead, the one that I double checked has a dot on it, which then provides power to all 8 of these switches. So since we're going to be doing a basic NAND circuit today, I've only wired these first 2 circuits, or these first 2 switches. So you can see on the opposite side, we have both of these switches tied to ground. So this is going to be a simple switch layout that you are going to do every single time when you design a switch and LED circuit in this class. So it's very important that you learn this layout and you're able to replicate it consistently. So I'll just go ahead and reiterate one more time. It's this power going into this leftmost lead of the SIP resistor, and then on the other side of this, this switch package, they'll all be tied to ground, where you have your numbers here on the bottom, and then you have some small text up here at the top. So these 2 red wires are actually where the signal input is going to come from. So as you switch these switches, the digital signals on these 2 red wires will switch from 0 to 1. So moving on to the next part of our circuit, this is going to be our chip. So I'm going to remove the chip from the breadboard and show you a little bit of how this works. So in this video, we're going to use a 7400 chip, which is otherwise known as a NAND chip. So you're not able to see very clearly in the video, but if you examine the last 2 numbers, you'll be able to make an easy differentiation on what chip you have. So in this class, the 2 chips we use are the 7400, which is NAND, and the 7402, which is NOR. So actually put this chip in, 1 hole to the right. So I'm going to make sure I align this back to our original design so we don't have any bugs. So one thing that's important to note with these chips is that they all require power and ground. So you can see this top left lead right here is connected to power. When you number these pins, you start here, you work your way down to the right, and you go up and then go back down. So this is power, and then we'll connect this one to ground. And you can see we have our 2 inputs going into these first 2 leads, and the output of the NAND gate coming in from this black wire. So you may be asking, how do you know what the configuration of this integrated circuit is? Well, I'll show you if we go to our website I'll go ahead and share this screen so you can see. So this is what a data sheet would look like. So you can actually get to this. So if you navigate to the home page of our class, Digital Logic and Computer Systems, you can scroll down here to this link that says 74HC XXX data sheets. So if you click on this, it'll redirect you to this website. And like I said, the 00 and the 02 chips are the two chips we'll use in this class, but there's a whole bunch of different ICs you can look at. So since we're using the 00, I'll click part number, and it'll give us a short spec list. And then we're going to click this data sheet under technical data. So this will bring up a PDF, and it'll give us a nice connection diagram of how this is wired through our IC. So now it makes sense why we have our two inputs on these first two, our output on the third lead. And as I said, it counts 1 through 7, goes up, and then counts back. So it also tells you right here that VCC needs to be in pin 14 or the top left. And that pin 7 here is going to be ground. And you know you have this orientation because if we return back to the breadboard, there's a small notch right here on the center, or center left. So this notch is always going to be on the left side. You should be able to read the text from left to right normally. And that's how you know you have your chip lined up to the connection diagram on the website. So we can see after this part of the circuit, the output is going to go to this other black IC. So this black IC is actually called a dip resistor, which is the dual inline package as indicated by the dual lines of leads right here. Not to be confused with what this is called a SIP resistor, which is a single inline package. So in your lab kits, if you're taking the class more recently, this dip resistor will be in the form of a green printed circuit board, and it'll have connections straight across. So from one side of the IC will connect directly to the other side. But this is the IC we used as a dip resistor in previous years. So this is what I'll use in this video. So you can see the output goes into this resistor, through the resistor, and then out here on the other side where it will then connect with the LED. So now moving on to the LED, I'll go ahead and remove it and give you guys some important information about this LED package. So here we have an LED package where each one is individually an LED. And you can see on one side, you kind of have this lettering or text. And on the other side, completely blank. So this side with the text is known as the anode of an LED, which is where you're going to be wanting to supply power. So in this example, I have it set up like this. So this right here is actually an active high LED, and you can tell because our output signal is going into the anode side, and this cathode side, without any text or any lettering, is wired to ground. So I have my DAD plugged in to power and ground. Normally, you would use your DE10 light to supply the 3.3 volts, but I'll go ahead and turn it on and explain how it works. So as you already know, in digital logic, whenever we create a circuit, we create a truth table and then a voltage table. So if you're looking at the voltage and you want to check to see if your circuit is right, this configuration right here is considered the low. So if you follow the sequence of binary counting, this would be low. And if I flip this second one down, it would be low-high. And then if I switch these two, this would be known as high-low. And then finally, both down would be high-high. So notice how the LED turns off on this last configuration at high-high, but it stays on during all other combinations. So let's go ahead and take a look and give a quick explanation for why this might occur. So you go to Microsoft Whiteboard, and then so how this might happen is like I said, we have a NAND gate. So a NAND gate is like this, and it's easy to remember the name NAND because you can think of N like end. So NAND end. So the bubble is going to be on the end. And in this example, we're assuming the two inputs are something like A active high and B active high. So these two signals will feed into our NAND gate, and then it'll come out to what we have configured the circuit to be an active high LED. So we'll call this output C active high. So if you've done the homework and you know how to analyze this circuit, we can pretty easily derive an equation from this. So here we have no mismatch between our input and the input of our gates. So this will just be signal A. And same for B, this will be signal B. And it is important to note that there actually is a mismatch between this bubble on the output and this C active high. So we'll have A, B, and because of this mismatch, we'll have to negate the entire term. So you can say that C is equal to A and B all knotted. So if we do the truth table for this, we'll have A, B, and C. So we'll go ahead and configure this like we normally would a truth table in counting order. And we can look at the outputs. So I'll actually add one more step here to make it a little more clear about what C actually represents. So we'll say this intermediate step is A and B, and our final step is C equals A and B all knotted. So we'll go ahead and fill out this first column, A and B. So of course it's a simple AND, so it'll be true when both outputs are true. And then when we knot it, we simply flip whatever's here to here. So it now becomes 1, 1, 1, 0. So what this tells us is that we're sending a true signal into our active high LED in every combination except for this last one. Okay, so now this kind of explains why when in every configuration the light is on, but then in our last configuration it's actually off. Okay, so when you're dealing with these switch and LED circuits, it's important to note these activation levels. All right, so now I'm going to go back to our circuit and we'll do a quick overview before ending this video. So some important things to note, this SIP resistor, it's very important you have the black dot on the left side and these two sides connected to ground and your signals coming from this resistor side. Make sure for all of your ICs, for your gates, make sure that it's sufficiently powered with power and ground here. Make sure to always use a resistor as to protect your LED package, and so none of these LEDs explode or burn out unintentionally. So that was a quick review about how these components should be done on a breadboard, and make sure to look out for any other videos regarding the switch and LED schematics.